Let's talk a little bit more about adaptation. If climate changes, people and companies would change their behavior to alleviate the negative consequences of climate change and make the most of the positive consequences. Because of adaptation, the impacts of climate change are not nearly as bad as they would be without adaptation, and that implies in turn that there's less need to mitigate climate change is not as bad. So therefore, at a policy level, adaptation and mitigation are substitutes. For this reason, in a lot of circles, policymakers, activists did not want to talk about adaptation because essentially it was seen as an admission of defeat. We cannot avoid climate change, but this has now changed, at least in some circles, because people have begun to realize that climate change cannot be avoided altogether. There's another aspect to this, and that is for successful greenhouse gas emission reduction. For successfully avoiding climate change, you need collaboration or coordination between all major emitters, whereas adaptation is something you can do in your own country or in your own community or even in your own household. You do not need global collaboration for this. So how to adapt? Well, for most systems, for most impacts, this is actually not a major issue. If you're a wheat farmer, you plant your wheat and 4 or 3 months later you harvest. So what matters is the weather over the next 3 or 4 months. The climate in the year 2050 or in the year 2100 is completely irrelevant for the success of your crops. Their adaptation decisions are actually quite trivial and would come automatically. If you take a tourist resort, you may think, well, these things last a long time. You would actually be wrong, because tourist preferences are fickle, and therefore investors would expect to earn their money back in 5 or 10 years. And that means that what matters is the weather over the next 5 or 10 years, not the weather over the next century. Other things last much longer, dikes and bridges and those sort of things. Coastal protection, that is supposed to last a century or so. But if you're protecting against sea level rise, then yes, there is a lot of uncertainty about the future, and we don't know how much sea level would rise, but we know the sign of sea level rise. We know that because of climate change, sea level can only go up. The projections for this century are somewhere between 50 centimeters and perhaps 150 centimeters. So if you're planning a dike for the next, that should last the next 100 years, then you just take the top end of the scenario and you plan your dike for 150 centimeters of sea level rise. And if it turns out to be less, then you're just lucky and your dike will last a little bit longer. And these sort of marginal adjustments are actually not that expensive. Just raising your dikes by a little bit doesn't add a lot to the costs. So the question how to adapt only becomes an issue if you have long-lived infrastructure and you don't really know the sign of the change. And that is the case for anything that has to do with water. Now what you're looking at here is a projection or a collection of projections, an ensemble of projections of projected patterns of rainfall across the world. And we're looking at one particular scenario, but we're looking at 2 different seasons. This is the northern winter, December, January, February. This is the northern summer, June, July, August. In blue, you're looking at places that get wetter. In brown, you're looking at places that gets drier. Some places like south of England, for instance, what we see is that in winter it would get wetter and in summer it would get drier. So that explains why some people say climate change will bring more floods and droughts, not at the same time, but in the same place at different times in the year. But that is actually not what I would like to draw your attention to. The other coding that you see here is that it's in the areas where there's little dots that there is actually substantive agreement between models about the sign of the change. And the scary thing here is that in many parts of the world, there's actually no agreement on the sign of the change. So if climate changes, then if the world gets warmer, then you betcha that your rainfall will change too. For two reasons. If the world warms and the world warms unevenly, you would see changes in pressure patterns, and therefore changes in winds, and winds bring clouds, and that would mean changes in rainfall and snowfall, and that is one. And second, if the atmosphere warms, it can contain more water vapor, and therefore, for that reason also, you would expect to see changes in rainfall patterns. So you can betcha if the world warms, you see changes in rainfall. But it is actually in many places of the world, it is hard to predict whether it will get drier or wetter during a particular season. And that is a challenge, because you know that you're building long-lived infrastructure, and you know that the future will be different, but you don't know how the future will be different. And that means that you need to think hard about how to do this. And essentially, the sort of adaptation that you need is either make your system more robust, just put more concrete on it so that it can withstand basically everything. That is not always a good solution. Hard infrastructure is not necessarily a good solution to adapt to a future that has fundamental and large uncertainties. Going back to the flooding problem in southern England, well, one thing you can do is drain your rivers, and then the water would flow fast to the sea, and your flooding problem has been solved. The problem is that the water would not only flow faster in winter, it would also flow faster in summer. And therefore your drought problem, your solution to your flood problem, would actually exacerbate your drought problem. So that is not a good idea. So you perhaps do not need to think in terms of robustness, but much more in terms of flexibility, where you can adjust your system, and retention areas would be a better solution to this than drainage, where you can store water in a place that it doesn't do much harm in winter, but you must store the water so that you can actually use it in summer. So you need to think in terms like this. But if you don't know how things are changing, then perhaps pouring concrete is not the solution. It's not a matter of making the system bigger. If you're uncertain about future sea level rise, then you just raise your dike, and you just raise it to the maximum to make the system more robust. But if you're not sure whether you need to raise the dikes or perhaps lower them to, for whatever reason, to cope with drought, and then what you need to make sure is that you can change your system as you learn more about what the future will hold. As the future unfolds, you can update your plans, and you can update your waterworks. And therefore you need to think creatively about how to do that. And pouring concrete is then probably not the answer. Now, the good thing about this is that engineers love to solve this kind of problem, and therefore you should just be aware that this is, and you should get your creative and good people and smart people to design solutions for this. But I emphasize that this is the exception, that long-lived infrastructure that is water related is essentially the only problem where adaptation is a technical problem, that you actually need to think hard about the technical solutions. For most systems, adaptation is actually quite simple and quite trivial, because many of these systems turn over much faster than climate will change. And to illustrate that, I'm going to again put up this picture of the Grunsberg rule of adaptation. That yes, these beach, the people on the beach renew themselves every 2 hours, so you don't really need to worry about them drowning for sea level that may come over the next century.